In this video, I'll explain where the mathematical models come from for resistors in series and resistors in parallel. I do not expect you to be able to reproduce what I'm doing in these videos, but I do expect you to be able to use resulting mathematical models. So if we look at this circuit, it's got one battery and then three resistors, and these resistors are all in series. You can see that because if current leaves the battery from this positive side, it has to pass through every resistor in order to get back to the battery. There is no place where it can choose to go another route to get back to the other side. So these are all in series. So since they're all in series, every bit of current that comes out of the battery goes through RA, goes through RB, goes through RC. So I for the battery equals IA equals IB equals IC. We also have the loop rule. So Kirchhoff's loop rule, remember, says if you compare the voltage at one point in the circuit to that same point in the circuit when you come back to the same point, it's the same. So what that says about this circuit is change in voltage around a complete loop. If I start here going clockwise, this is the plus side of the battery, that's the minus side of the battery, so current is flowing this way. I'm going to put in the pluses and minuses so I don't forget. Now since current is flowing this way, that means it's flowing from a higher potential to a lower potential. So the plus side of this resistor is here and the minus is there, and the same, this is plus and minus, plus and minus. So I gain plus V battery here, and then there's a V across this resistor A, and I'm going from the plus to the minus, so it's going down. So I have to subtract VA. And again here, I have to subtract VB. And here, I have to subtract VC to get back where I started. So 0 equals V battery minus VA minus VB minus VC. And if we rearrange this, we get V battery equals VA plus VB plus VC. Now what if we use Ohm's law? V battery equals this VA, V equals IR, so VA is IA times RA, VB is IB times RB, VC is IC times RC. So V battery is that. But remember, all the currents are the same. So I can actually factor the current out and just call it I of the battery. So V battery is I of the battery times RA plus RB plus RC. And V equals IR, that means this must be the R that the battery sees. So the battery sees RA plus RB plus RC as being the equivalent resistance of the whole circuit. That's what REQ is, equivalent resistance. Now for resistors in parallel. Here we have a battery, and the current can leave the plus side of the battery and pass through resistor A and come back, or it can choose to pass through resistor B and come back, or it could choose resistor C. Since it can choose all these different paths, we know that they're in parallel. I'm going to put my pluses and minuses in here again. I can look at this entire top piece as one big junction, because all that's here is wires. So there's one wire going into this, and then there's current coming out of it in three different places. And I know that current in equals current out, so the current of the battery going in has to be equal to IA plus IB plus IC. That's what this is. The loop rule says change in voltage through a loop is 0. So if I go plus through the battery minus VA, that has to be equal to 0. So V battery equals VA. And I can do the same thing looping here or looping here to find that the voltage on the battery is the voltage on A, which is the voltage on B, which is the voltage on C. Then I can do the same thing we did before using Ohm's law. I come back up here. I of the battery equals IA. IA, V equals IR, so I equals V over R. VA over RA, except I know that VA is the same as the battery. So this is VA over RA plus VB over RB plus VC over RC. But since they're all equal, that's the same as V battery over RA, RB, and RC. Then if I divide both sides by V battery, I get I battery over V battery equals 1 over RA plus 1 over RB plus 1 over RC. Now V equals IR, so I over V actually equals 1 over R. So this 1 over all of these things equals 1 over the equivalent resistance of that circuit. So when resistors are in series, you can just add them. When they're in parallel, you have to take the reciprocal of every one, add them all together, and that gives you the reciprocal of the equivalent resistance. So don't forget this is 1 over R, this is not R. That's the most common mistake that people make with resistors in parallel.